Hello, folks. Welcome to another stream here in my bedroom because it's storming pretty crazily where I'm at in the world. I'm not sure if you're able to hear any of the storm out there. There's also a fan on in the background slightly, but it's soaking the combo classroom, going pretty absurd. Some of the areas, not exactly where I live, but not far, have flooding and bigger problems right now. I guess there's a small chance the power will get shut off if a tree falls on something because they warned there's a chance of that. So if the stream ends early, stay tuned for in case I leave a comment that's like, no, the power went out. But hopefully that won't be the case. Hopefully we're just getting a free clock washing on all of our outdoor clocks while we stay sheltered in here. And I'm saying we, not just me and any viewers, but also my soft cat Dandelion, who's that blob over there, which as soon as he wakes up, I'll make sure to give some good pets to. And um, hello to our first little comments here. We'll have to check out the storm later in person. I do have footage of some flooding that happened last time it was super rainy a couple days ago when part of my yard flooded. I dropped a short of that, and there will be some more footage of that in some upcoming main channel full episodes. But also, I'm not even sure if I'm going to be able to film tomorrow. I'll film whatever's going on in the yard myself, but I'm not sure if my cameraman's going to be able to make it here because it's chaos in the region. However, luckily, right here, the worst that'll happen is our yard gets like a foot of water, which is pretty chaotic, but we're not next to like a river that's going to flood or anything. Theoretically, maybe the power could get knocked out here tonight if a tree falls. Let's hope not. And then tomorrow we'll see how the clock washing is going. Now, some of the clocks were made of wood that I've accumulated, and those ones, some of them got moldy and crazy. So we're going to have a clock destruction documentation ritual to replace some of our clocks with fresh ones at some point, maybe in our grade -1 finale. Today we will be talking about clocks a little bit. I'll get to that in a minute, but we have just passed a special number of subscribers here, or as I call you folks, combo lords, on this channel that happens to line up with a nice clock number. So we'll get to that in a minute. Look up some fun facts about that clock-centered number. But in any case, let me start out by giving some upgrades about our grade -1 status. So some people thought maybe the new year would be the new grade. No, 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 no. We don't follow the Gregorian calendar to tell us when we should be ready to have accomplished what we need to accomplish with the grade and be ready for a cycle to restart. Now, in some ways, the next grade will be a further deeper evolution of things, and we will go maybe a little more chaotic and more surreal and maybe a little stranger at times. However, it also will be a reset of sorts, like hitting a midnight on a clock again, back to 1, except we're modular, so we treat the top like a 0. Getting back to the 0 on our mod cycle, we may see some resets mixed in with the chaos, because things come in cycles. So I am anticipating that I think the grade -2 will officially be coming out on April Fool's Day, a very cool day. Maybe that's just a prank. Maybe it's not coming out that day. But what I'm telling you now is that on April Fool's Day, we should expect grade -2 to launch. Now, that leaves us January, February, and March. And what I want to get up to is the base 6, what looks like 100, the 100 number in base 6. Amount of episodes on my main channel. All of this bonus channel stuff is fun. I love doing the streams and shorts and stuff, but really I'm measuring where we're at in the grade on my main channel episodes, where I fully craft out my little chunks of knowledge and art for you guys. And so on those, we have about maybe 8 or so of those to go, including an interesting finale before we hit the end of the grade. And these might be a little more spread out to give myself a little time to make them a little longer and flesh out a few concepts. The next few episodes will be coming out pretty quick. I'll have one about bubbles and rain, which is sort of like snack break vibe, but more of a science break with some fun bubble experiments and some facts about rain and bubbles. That'll be dropping in a few days. And then on Friday the 13th, I'll have one dropping about calendars. And then later in January, I will have the one about Base 2i that everyone's been requesting, which will sort of finish off a little trilogy I've done on there that I've done the first two of unconventional numerical bases. It'll probably end up being more than a trilogy because these aren't the only ones I want to share. There will be more unconventional bases in grade -2, but grade -1, I need to fit in that third part of that starting trilogy where we've done our negative bases, we've done our fractional and irrational bases, and we will now do our complex and imaginary bases. So that'll be coming out in January, and then the remaining 6 or so episodes will be coming out throughout February and March, so maybe more like 10 days between them instead of like 6 days, but they'll be a little longer for some of them. They'll be extra cool because some of them are topics that I've planned since the beginning of grade 1 that I've wanted to make that I didn't get to yet because I held them at some higher esteem, that I thought I really can get this topic cool if I get it right. And so some of them will have to be a little longer, a little more care. The videos might cost a little more to make, but they'll be really cool. We're gonna have some really great topics wrapping up the end of this grade. And then we will have a longer finale, which I'll make sort of like a mini documentary about the process of making this grade. That'll be a little more behind the scenesy and maybe a little more philosophical as opposed to straight up math. And that will relate to some crazy things I went through in 2022, such as going through 2 surgeries while I created these channels. Major surgeries, a surgery on each hip, and that's an intense ordeal that I will show more footage and stories of. Maybe I'll chat about it later in the stream because we did just pass 2022, so maybe we'll have some 2022 memories, but most of that will show up in some longer behind the scenes like episodes. Also, some of that is given to my Patreon supporters early, so some of the rare behind the scenes is already up on Patreon. Now, someone's saying, isn't the answer as simple as 86,400? And yes, the answer I gave away in the title, that's the number that's special. What we're going to do, though, is note that has a very simple relationship to clocks, which is that's how many seconds are in a day. However, we're going to see what other fun facts we can find out about that number, some of which relate to factorials, and we'll see why those are sort of fun half coincidences where it wasn't purely planned that the number of seconds in a day would have traits like these, but that the fact that 24 and 60 are really divisible, and divisible numbers get some cool traits, makes 86,400 pretty divisible and have some traits. So now we are going to go to my computer screen view in a little bit once I'm done with a little intro, and we're going to look at a few websites I've pulled up that have details about this number. I already have a few sources we're going to comb through. Someone's wondering about a 30,000-foot view of the grade structure. It's a little vague of the grade structure, if you mean like what order the grades will go and stuff. The grades will be going forward in negative, and by forward I mean further from the origin, larger in absolute value, further in the negative direction. People have already done the positive direction in normal school. The negative direction is unclaimed terrain for us to get wild with. Now, we're just going to go down in the negative grades, and to a degree, they're just like different seasons of a TV show or different little arcs of my life. So, To a degree, they're just a new grade we're in. To another degree, each grade may have its own little arc, its own little particular themes that are extra emphasized, its own little cycles or recurrences. Some of them may have an interesting shift at the beginning of them, although this grade, for sure, I'm not taking off too much time. That super long finale will be coming out mid-March, and then the grade will start at the beginning of April. So we're not taking a long summer, spring break or whatever. Your spring break's going to be like a week. And I'll probably still be streaming that week. So, also about streaming, I mentioned recently that I will be announcing a stream schedule soon. I'm still shuffling around some stuff with my private students because I have like a day job I still have to do to survive. I don't make as much money as I spend on combo class yet, let alone enough money to survive on. I still spend more than I make on combo class. So I still have a day job and stuff, which is teaching private lessons. So I'm shuffling around some students to try and get those on fewer days so that I can commit to a stream schedule every week and have a few days that you know I'll be streaming at a particular time. And random ones as well. Someone's wondering if I want any logo or intro or help with production. And yeah, I'm always down to chat with people who know any type of video editing, any type of graphic design, any type of particular technical skill like that, and want to help out. Definitely. I'm still expanding my team of helpers. Most of the people who have made this show with me are just my friends who I just pay a small amount of money or buy some food and they help me out on my show. But I need to build a bigger team, and I still need to get back to a bunch of people in my emails. There are people who have helped me out and who are awesome. I got a few cool like mods on my Discord and stuff. But definitely reach out if you or anyone does have a technical skill that you want to spend any time helping me out with. It will be, for the good of the world. We are spreading education and fun. And if you help me design anything really cool, I'll certainly credit you. So yeah, my contact link is on like the about page of these channels. So people can always feel free to reach out if they genuinely think they have a way maybe to help. Even if it's just some random little skill or interest. And thank you to everyone who loves the channel and or channels. I hope all of you are tuned into both of them. If anything, I hope you guys have your like notifications on for the main channel. The other one that's just called Combo Class, because those ones, like, I feel like people should see every single episode on. This channel is going to have a lot of random content between the shorts and the live streams, so this channel is more like see whatever content you're most interested in or have time for. But there's going to be a lot of content. Maybe there'll be a few diehard fans who watch all of it. But the main channel, especially, make sure you have your notifications and stuff on for, because every episode I put on there will be super cool. So, yeah, and I do love putting my time and money into this. It feels good to do, so I am happy to continue doing that, and hopefully, as I assemble a team and more resources and stuff, hopefully then I can spend more and more time on the creative parts of it I love, and not the parts that are tedious. So we shall see as it evolves. In any case, that's what we got anticipated for the upcoming on the main channel. Got a bubble episode, you got your Friday the 13th calendar episode, you got your base 2i, and then you're going to get episodes about every 10 days instead of every 6 days. In the next 2 months, that will be slightly longer, extra cool episodes. And then grade -2 will be not far from now. And to whoever's saying to reach out on Discord, if you want to reach out about helping with any like editing or production stuff, people can reach out to my email directly. I'm okay with that, which is on the contact or about page. But I also check the Discord when possible. I like chatting with my people there when I have the time. A lot of cool thoughts going on there. Also, want to draw more people to the subreddit, which has a few awesome posts, but we need some more action there. and of course to the Patreon for extra helpful people, I just gotta say. Now, apart from that, we are going to have hopefully a few field trips in the rest of the grade. Now that I'm recovering from my surgeries more, I'm able to walk pretty regularly. Maybe we'll be able to go down to the marina or to the forest or on some cool field trips. Still not sure if my stream's going to work with the right connection to stream that. I'll try. Or if we'll just have to record while I'm there and put that in a video of some sort. But some fun field trips will be in store. In fact, there's one particular field trip to a kind of clock-like thing that I'm sure I'll be making at some point in the season or grade. And what's my favorite number is asked, and what I'm going to stick with is that I cannot pick a favorite out of the iconic, ultra classic, properly highly rated constants, the ones that get a lot of credit and deserve it. You know, your 0, 1, I, -1, pi, golden ratio, e. Those numbers are pretty hard to beat. Can't pick a favorite out of that like common favorites club, but I can say what I think is the most underrated number, or what I think is a number that deserves to be on that list but isn't, of the top all-stars, which is 6. 6 is awesome. 6 has so many properties, which I have ranted about in past videos, and sometime I'll make an even more thorough compilation on 6, but I need to dig up this fact about it. I read a fact that I couldn't find the proof, which was that apparently 6 is the only triangular number whose square is also a triangular number, 36. And I couldn't find the proof. I found the book that it's supposed to be in, but I couldn't find it online, and it's like $1 million to order. And so I'm going to have to go to a library to find this book to find the proof, because I don't want to make an episode about a fact that I'm not sure about. So I saw that statement, but I have to wait to make my episode about 6 until I can go to some library and find the actual confirmation of that fact. But that's just one out of a billion things that are cool about 6. But the random note we'll talk about today, because it's our clock theme, is that did you know that there are exactly 6 factorial minutes in a 12-hour span on a clock? 6 factorial minutes. Now, why is that the case? Well, you got 12 times 60. Those are both pretty divisible. 6 factorial means we should be multiplying the first 6 numbers together. 12 we can call 3 times 4. We can call 60 5 times 6 times 2 times 1. And there you go. They line up. You can rearrange them. What can you rearrange the amount of seconds in a day into? Well, I think it's time to check on my computer screen. So, we are going to now shrink my face and look at some things. Here we can see that in the list on Wikipedia that they decided to put the importantest selected numbers in the range 80,000 to 89,999. Well, the only number in the 86,000s that got in there is this: the seconds in a day. The amount of combo lords we just passed. How awesome. Now, normally I sometimes make like a subscriber special Q&A thingy when it's a round number in our base, like 80,000 or something, because that's catchy as a title because people like our base. But I'm even more fond of the numbers that actually have cool properties, like 86,400. Now, it's not really arbitrary that like, oh, we happen to pick 24 times 60 times 60. There are other combos that would have multiplied to this number as well, because of 24 and 60 being so rearrangeable into other numbers. So, how about this? When we go, we're going to pull open Wolfram Alpha and just use their calculator. And what if I say, what is, calculator, 1 times 2 times 3 times 4 times 5 times 6 times back down. What do you guys think I'm going to get? I multiplied up through 6 and then back down. Well, what do you know? 86,400. That's funny that the input, what they put here, that they got input, didn't include the first one, but included the last one. That's interesting. In any case, our result was 86,400. How else could we write this? We could write this as 6 factorial times 5 factorial. 86,400. Now, some of these traits are why, if I look this number up in a cool place called the Online Encyclopedia of Integer Sequences, well, I'm looking up what integer sequences, such as the Fibonacci sequence or triangular numbers or powers of 2 or some sequence like that, has been cataloged that has this in it. And here's one. They wanted to make a sequence of, since they did have a lot of cool traits it had, apparently, of n factorial times n plus 1 factorial. And this is what we get for the 5th number, because it starts on the 0th number. So we can see, yeah, 5 factorial times 6 factorial sits right there. Hey, what's up with this number? That number is very familiar. That looks just like a factorial. 7 factorial times 8 factorial. That one is a factorial, isn't it? What factorial would that be? 10? Yeah. So, yeah, I forgot that cool trait. Even though that's 10 factorial, it's also 6 factorial times 7 factorial. That's another example of how rearrangeable they are. 6 factorial times 7 factorial gave us 10 factorial. Well, this number is not a factorial itself, but it is 2 neighboring ones multiplied. Now, we can look at other sequences and see that there's another way to make it here, where they multiplied by 1, then times 2, times 2, times 3, times 3, times 4, times 4, times 5, times 5, times 6. And that got us there. Here's one that is called highly powerful numbers. Whole different story. This is also a number that has a record value of the product of the exponents and its prime factorization. Now, you know, like highly composite numbers mean they beat out smaller numbers in terms of divisors. Well, this means it beats out smaller numbers in terms of the product of the exponents and its prime factorization, for beating out smaller numbers. So that's pretty neat. It's a highly powerful number. Pretty epic title to give a type of number. There's also just powerful numbers, but they had to clarify this one's highly powerful. It's also this thing called an Achilles number. Achilles numbers are numbers that basically each number in their prime factorization has an exponent of at least 2, but they are not a perfect power. Something along those lines. And we get some other random sequences it's in. This one comes in between some strange ones. And some more stuff about products of factorials. Smaller member of an infinitely amicable pair. Oh no, infinitary amicable pair. And this is different about infinitary divisors, it looks like. So different type of thing than normal amicable numbers. But this would refer to whatever the infinitary divisor sum of this, that number's infinitary divisor sum is this. So there's a whole nother thing it is. An infinitary amicable pair's lower number. And this. And more. So, a lot of cool things that this number is. But that's just the start. Here's a website that catalogs different traits about numbers. And look at all these traits. Powerful. Achilles. This thing that describes numbers that are products of distinct factorials. Divisible by the number of its divisors. It's a multiple of its sum of digits in our base. It's this cool one called a congruent number, this cool one called an unprimable number. It's all sorts of stuff. So, yep, a lot of cool things going on there. So, there's a number for you. That is the amount of seconds in a day in its more true form. 2 to the 7th power times 3 to the 3rd times 5 to the 2nd. So, those are our facts about our lucky number of the day. Thanks to all the comments. I might go through and try and answer more in a little bit. For now, I wanted to ask that robot. Remember that chat robot? So this is for people who didn't see my earlier streams. This is like this popular chat robot you might have seen memes about or stuff, or like people talking about how smart it is. And it is really smart at answering certain things. So like if I ask it like, tell me a history of the twin prime conjecture, it's maybe will have like an error somewhere in it, but it's going to be like super elegant almost for a robot in describing this stuff, because it's good at compiling history. I mean, not going to say it's accurate. I haven't checked that much, but it's at least elegant at its phrasings when compiling history. Someone mentioned something about connection to the lazy caterer numbers. I did make a short about those a while ago. Those will recur more in the future when I do some more full episodes related to triangular numbers. Triangular numbers are one of my favorite types of number, and they're in this family called figurate numbers that includes square numbers and other types. And there will be a variety of episodes about those in grade -2 because they have a lot of cool traits. So that they're really elegant about. Now, how about this? Tell me something interesting about the number 8640. Now, they'll probably get the seconds in the day. So then we might have to cue it to go more mathy. And last time we asked them things like this, they were so comically wrong about all the numbers. They were so bad at knowing facts about the numbers. It's the number of seconds in a day. So that's true. Another interesting thing is that it's a composite number. That's a true trait, but not very interesting about it. Now, they got this a little wrong. They tried to write a bunch of 2s as if they're included. Oh, wait, no, it doesn't even have a 7 in it. Nope, no 7 in it. They got that from 2 to the 7th power somehow. Or as the product of all of these, this one's a lot closer, but they need a few more 3s and another 2 in the mix. It's also a perfect square, as it's the square of the integer number 300. You see what I'm... 300 squared. It's also a power of 2. It's also equal to 2 to the 15th power. All right, folks, let's see how off they are. 300 squared, 90,000. So they're only 33,600 off there. How about 2 to the power of 15? That's really small. That's less than half of it. This is closer to 2 to the power of 16. So finally it's used as a unit of measurement. Now that is true. They're just saying the seconds per day thing again. I want to hear more about this. Tell tell me more about how 8644 is the square of 300 and is also equal to 2 to the power of 15. All right, they're writing it out. This is true because when you multiply 300 by 300, you get 90,000, which is equal to 86,400. Here's another one. This is true because when you raise 2 to the 15th power, you get 32,768, which is equal to 86,400. Okay, let's see. If 86,400 is equal to 90,000 and also is equal to 32768, what else is it equal to? Okay, they're like, oh, no, they apologize. They're a little embarrassed here. They're trying to fix their mistake. Okay, they're going back. They got it. Only took them 3 tries. Okay. So, that one they got kind of right. So, what about other numbers that are related to clocks and factorials? One that I was thinking earlier is the amount of minutes in a 12-hour span we mentioned. That is 6 factorial. So, I want to ask them, tell me about the number 720 mathematically, and maybe they'll just say, like, oh, it's video resolution. They could say things about angles and polygons. They could say things about it being 6 factorial. They could say things about it's a highly composite number. And they could say things about it's the number of minutes in 12 hours. Let's see if they get any of those. And just to go real quick, just to show you what they could be saying. 720. No, not the year 720. Number. So they actually don't have that many things about. They write more about some other numbers. I don't know why they don't say as much about 720. It's a great number, underrated here, but they do say 6 factorial, highly composite. This is cool. So a Harshad number is a number that is divisible by the sum of its digits. And if you just see that on its own without it talking about what base we're talking about, it's a little base 10 centric. Could be interesting if we map its properties in multiple bases. So this is interesting when you note that whether you write your numbers in any base from base 2 to base 10 of all our normal integer bases, in any of those bases, however you write 720, it's divisible by the sum of its digits. Also, it has more answers to this type of number that will come up when we talk more about coprimeness, which will relate to these spiky star shapes we've done before that will occur a lot more. There's this one specific shape that goes, it's 12 dots on a circle, and you're going to the ones that are either 5 away at a time or 7 away at a time, does the same thing backwards, and it makes it fully spiky. And that shape already showed up in a big way in an episode about prime numbers and about what digits prime numbers can end in different bases. And then the shape recurred in the Roots of Unity episode, just as a hint of what the 12th roots could look like, although we didn't fully elaborate on that yet. And it's going to return in a music theory episode. It's going to return in this other one about coprime numbers. It's going to return in these other things. It return in things about which fractions can simplify or not, which it relates to the coprimeness, things called fairy series. That shape is going to be an all-star in the first couple grades. It's expressible as the product of consecutive numbers in different ways. It's multiplying the first 6 numbers or multiplying 8 through 10. That's nifty. That's related to that other trait we saw about 10 factorial having some other similarities, but that's a good one. It is also kind of like triangular numbers. It is a 241-gonal number. It's probably like the second... The 241-gonal numbers probably go like 1, 241, 720. I don't imagine there's others in between that, probably. Maybe one in between. I doubt it. So, um, let's see. Someone's wondering if it's only conjectured or proven whether there's only 3 pairs of numbers that the factorial is 1 under a perfect square, which was in one of my recent shorts. And that's just conjectured. It's not proven yet. So a lot of mathematicians think that since a high enough range has been checked, and factorials and squares get rarer each as you go up the number line for a stretch of numbers, that like probabilistically it's less likely that there are any more, but it could be disagreed on and hasn't been proven. Some people want to ask it about Chaitin's constant, which is a pretty complicated one. I'm probably going to ask it more about stuff that I've already explained to the class, but we will go into that more when we go into weird irrational numbers. Someone asked if I can reply to their comment, but I can't see it. Can you repost your comment to whoever asked if I can reply, unless you are on a different account or something? Yeah, thank you for those thoughts. This is another good number for us to see what it knows about. It's equal to... Wait, what is this? 16 times... So that's not true. What is its prime factorization? 2 to the 4 times 3 squared. We need another 3 in the mix there. And we need another 2 in the mix there. And it's not 24 squared. And it's not 12 cubed. How far off are these? 24 squared. 576, okay. 12 cubed. 1728. That is more than twice this. This is literally closer to 12 squared than 12 cubed, arithmetically. So, and the fourth power, 6 to the fourth power, where are they getting all these? 1296, no. Now, these ones are factorials, so maybe they got confused by reading about a bunch of factorials next to each other. But I don't know where they're getting this stuff. It can also be written as the product of other numbers or as the power of a number. This is restating their wrong facts there. Oh my god, these are really off. Okay, let's go down a factorial. We may have already asked them about 120, but we can ask them again because 120 is a good one. Well, let's go up a factorial. How about 5040? It's equal to the product. They like doing these, but that's way too small to be 5040. And they can't have a prime factorization that's just different. You can't have a number that's equal to this and also equal to this if both of them are in prime factorization form. And this one, they're close. This is one of those Brown number pairs. So look, they're finally not correct, but close. 70 squared is... Oh no, it's that 71 squared is 1 off from... So 1 more than 70 squared is 1 more than our target. Maybe that's how they mixed it up. They say it's also equal to 20 cubed. What's that? 20 cubed. 8,000, yeah. Fourth power of 7, no. Yeah. Oh man, they really like assuming that numbers like this are squares and cubes and fourth powers and all sorts of stuff. What's another number that can be written in several different ways? Almost any integer. Here are a few examples. 120 can be written this way, or can be written as 10 squared. 36 can be written as... These are also just not right. They're not putting enough in. Or as... Oh, it is 6 squared. Oh, they got part of an answer right. Praise be the computer. Half an answer right. 48 apparently though is also this. Okay, I'm removing the point of credit I gave them for claiming that 36 is 6 squared, which was correct because they 1 or 2 sentences later claimed that 48 was also 6 squared. Please give me more examples. It's so proud. Certainly. 256. Okay, can be written as that many 2's multiplied together, or a different amount of 2's multiplied together. 500 can be written this way. That's 100. Is that? It can be written that way. That bit's correct. 25 squared, not correct. 1,000 can be written these ways. Or as 10 squared. Okay, they're a magnitude off. Could have been a 3 there. Okay. So, someone said just to ask about the relationship between factorials and squares. That sounds good. What is the relationship between factorials and perfect square numbers? Some factorials are also perfect square numbers, but not all factorials are perfect square numbers. The only factorial that's going to be a perfect square is going to be 1. Some examples are 4 and 16. Yep. 9. Yep. The factorial. Okay. The factorial of 6 is 720, which is also equal to the integer, the square of 24. However, not all factorials are perfect squares. For example, I thought you just said that was a perfect square. They just said that 5040 is equal to the square of 70. All of a sudden, it's not, apparently. Okay. So, not perfect. Remember, people, only comment the same comment once, and then I'll make sure to get in touch with whatever comments I can. And let's see. So, a lot of interesting questions. So, someone's wondering why 69 became a trend and why not 55 or 96. Well, it's most definitely because 69 is the only number whose square and cube between the two of them contain all of the digits in base 10 once each. So that's definitely why. And there was another fun fact that I learned about it. So before I search 69, I'm going to search mathematical properties. Can't get anything else on my stream coming up. Mathematical properties has to come first here. Here's the one I mentioned. The only natural number whose square and cube use every decimal digit once. What other properties do we have? A lot of random traits. You'd be surprised at, speaking of meme numbers, how many mathematical traits 420 has. Sometime we'll have to go into that, because that is actually the smallest number that is divisible by 1 through 7. And ask the AI to solve the Monty Hall problem. I don't really want to go through writing out the whole Monty Hall problem setup to them with the 3 doors and the goats and the cars and all that. Maybe we'll copy and paste that from somewhere in a bit. But I like the idea of paradoxical things. So, what's a good... I'll just ask it to lead, and we're going to say, what is an example of a statistical paradox in math? Now, to people who don't like the word paradox, calm down. A paradox means something that seems counterintuitive or doesn't make sense. It doesn't have to mean a glitch in the universe. It can also just mean something that doesn't line up with what human expectations would comprehend. They did it. They did the Monty Hall paradox. That's funny. Am I the robot? You said Monty Hall and it made me think paradox. And when I told it paradox, it thought Monty Hall. So it's named after the host of Let's Make a Deal, who used to offer these chances. It arose because it seems counterintuitive that they would switch, but really it increases. So they did explain it right. So this is the type of thing they'll be better at, because they're like quoting a history-like thing. Someone's saying with multifactorials, what happens with the amount of factorials is greater than the number itself. I don't think you'd ever do that. I haven't encountered that. So I'm not sure if that would ever be used. So, yeah, maybe it's hearing us. Maybe it's listening. Maybe Chat GPT got bought out by Google or Amazon, or someone who's already listening to us, probably. So, yeah, let's ask 1 or 2 questions, and then I have a few other activities I want to do. Let's just do a few more numbers for fun. So, how about the golden ratio? Tell me some interesting mathematical properties of the golden ratio. Now, by the way, folks, want to give a quick golden ratio disclaimer. There are ways in which it is overrated and ways in which it is underrated, and I'm going to balance that out with a properly rated. It's held in pretty high esteem, and I think it deserves it, but it gets too much credit with its appearances in nature and not enough credit with how many different ways it shows up in math. It's not, at first I was obsessed with it because I'll tell this story sometime again about how I sort of stumbled into it myself in middle school and then later re-encountered it. And so I've always loved it. But then one of the first math books I bought consciously was about that. And then when I learned more about different types of irrational number, I was like, well, it looks a little more random in its normal way of writing it. 1 plus the square root of 5 all over 2. It just seems like this kind of random quadratic irrational number of the algebraic irrationals, maybe not as distinct as something like pi or e, or even something like square root of 2 on its own. Well, then I saw its continued fraction form and this square rooty form, and ways in which it can be considered the most irrational number, hardest to approximate, and other weird ways of making it. And then I was like, okay, you won back all my love. You are properly rated. Someone's wondering why not 24 times 360s. I'm not sure where they got the third 60 from. Because there's minutes and then seconds. Not really another division of 60. Someone's saying some OEIS sequence. I don't know which one you're referring to, so let's look it up because you piqued my interest. What's that sequence you're mentioning? 113,409, and I assume the next one will come up now. 23719. Number of different relations between n intervals on a line. And this is one you probably brought up because this came up earlier. So yeah, maybe this one will pop into some of those later ones. It also has our cool number 13 that I'm fond of culturally, and this Friday the 13th that's coming up. It might be the longest main channel episode yet, because I filmed the first half of it, and I'm supposed to... The next part of it is like the main part of it, where I talk about this weird calendar that may have 13 Friday the 13th every year, but be practical. And then I haven't even gotten to that part in the filming because I've just been like roasting the current calendar. There's so much to say about how bad the current calendar is set up. So hopefully I can film that second half tomorrow. We'll see what the rain does around here. It's been going crazy. Someone said, ask the AI to generate YouTube video ideas about combinatorics. That could be funny. I thought kind of similar to that asking it what could be a good direction to send it on topics that you guys like may know about and at least I know about is looking at some of the videos I've put out and asking it about some of these subjects, because these are things that I already know a bunch of facts about, and maybe some of you guys know facts about, and so it'd be kind of interesting to see their opinion on it. Like, let's ask it about the level beyond exponents. Let's say, oh no, we didn't ask the golden ratio. I'll ask the golden ratio and then we'll ask it about that. Okay, this isn't really an interesting property, but yeah. This isn't really an interesting property either. Yeah, see, this is the overrated parts. It does show up in some music and art and architecture and stuff, but this is a little overrated. This is also a little overrated. It happens at times, but not as much as some people say. This too, that's not as true. It's not as true. I asked you about math, guys. Come on. You didn't tell me any of the cool things about its difficulty approximating or its continued fraction form or any of its other cool traits with its reciprocal and so on. So now I'll ask it real quick about that video topic, which is if we call the early levels of mathematical operation succession, addition, multiplication, and exponentiation. Let's take off succession and see if they can get it just from here. That might lead them like onto too close to full lists of this. I want them to say what's after these. What level is after that and how does it work? The next level is tetration, also can be known as hyper 4. Involves iterating exponentiation. So far, whoa, 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 whoa. What's going on here? um, yeah, so with tetration, there's a lot of ways the symbol can be written, but the upward arrows they're probably trying to mean you get two of them. Kind of like one upward arrow is an exponent. So I think they meant here that they wanted 3 upward arrows, is what that 3 meant there. But, oh no, wait. Yeah, because 3 upward arrows, but that would be pentation. That's the whole next level. First we would calculate, whoa, yeah, what is this? 2 to the 3 to the 4 is not tetration. Tetration is when you take the same guy going up. A to the A to the A to the A. So 2 to the 3 to the 4 just isn't a tetration. It's just exponents with exponents. So, now let's ask it one more, and then we'll ask it to come up with a video topic. So let's ask it this. What is some interesting facts about flipping coins or rolling dice? Let's just go flipping coins for now. Let's see what they say about that. The probability of flipping a coin and getting heads is exactly 1/2. This is true for any fair coin. Well, yeah, it's a definition of being fair. If you flip it twice, the probability of getting 2 heads is that. Yep. If you flip it 3 times, it's an 1/8. Yep. So far, so good, but they are kind of being a little repetitive here. Yeah, I wasn't telling you that much cool stuff. So let's ask it one of the trick questions from the video. If you flip 4 fair coins, are you more likely to get A, or, well, let's say, is your total more likely to contain, in any order, A, 2 heads and 2 tails among the flips, or B, 3 of one kind and 1 of another kind in the flips? The other kind. Now, this is a trick because you think 2 heads and 2 tails has to be more likely than 3 of one kind and 1 of the other kind. But if we just say 3 of either one of the kinds, we'll say 3 of a kind, 3 of one of the types, then, and 1 of the other, that adds up to 3 heads and 1 tail, and the 3 tails and 1 head, which is more likely altogether. Now, yeah, they're not understanding me. They're assuming or getting tricked that, let's see. Oh, whoa, no. They're just completely off. Never mind. They're completely off. They're right that there are 6 options for getting this combo. However, they didn't list them right. This one they listed twice. This one they listed twice, and they skipped some. But they accidentally were right. There is 6 out of 16 likelihood that you get 2 heads and 2 tails. 3 of a kind and 1 of the other kind. They say there are 4 possible outcomes that fall into this. The all heads option, the all tails option, and 2 of the ones that are the 2 and 2s they listed earlier. None of these four are a three of a kind and one of the other kind. So they say case A is more likely to occur. Oh, and then they say the likelihood is just out of these. Like, these are the only options. So the chance of case A happening is 6 out of 10, because we had 10 we saw. And B is 4 out of 10. So yeah, they got that one pretty off. How about this? If you roll 2 6-sided dice, what is the most frequent number you would hit as the difference between the two numbers? So difference instead of sum, this most common sum you may remember is 7. Most common difference, you should see my episode about the coins and dice if you haven't seen it, but let's see if they get it. The difference is 7. They just took the answer from sum. Oh man, they're gonna list them all. Okay, no, okay, and so on. Good. Oh wow, they listed all the differences for there. So this is the funny thing, is they were listing correct differences, but then they say the value 7 appears most frequently, which it would never occur as a difference. 7 can't be a difference. Yeah, no, so that one wasn't right. Watch my episode if you want to see the right answer. And yeah, lots of interesting thoughts if people are recommending things to ask it. I think what I'll ask it next real quick is for it to suggest what we would want to put in a video about a certain topic. So let's say that what's a topic that may come up in the near future? Let's ask it if it can somehow try and do base 2i. And now, there's a tiny chance this will end up being a spoiler for some stuff we'll learn in the base 2i episode, but I highly doubt it's going to get it right. So, don't worry. Probably won't contain any knowledge spoilers. Actually, let's take it down the rabbit hole first with the other weird bases and ask it about the base -10 and see if they can do that. How would you write numbers in base -10? Using regular digits, so far so good, we can do that. 0, the digit 0 becomes -10. Wait, what? The digit 1 becomes -9. The digit 2 becomes -8. What are they doing there? Group the digits together according to the base. For example, in base -10, the digits are grouped in sets of 3, starting from the rightmost digit. I think they're saying where you put commas in a long number. That's just a trait of how we write numbers, though. That's not a trait of base -10. And then you place the negative base. What do you mean place the base? The whole point of a negative base, you don't use a sign before the leftmost group of digits. For example, this in base 10 would be written as that in base -10. No, it would not. So, yeah, they're not good at that. So, let's just ask it what they would put. What would be good facts and fun demonstrations of them to put in a YouTube episode about base -10? Here are a few ideas. Explain how it works and how it's different from other bases. Like, this actually was an example I gave, was binary. How to convert a number from base 10 to base -10. That's useful. Showing how they're related. This is weird that they think the digit -8 is equivalent to the digit 2. Um, presents some interesting examples, and the history. For example, you could mention that base -10 was used by the ancient Mayans, apparently. I think they used base 60 or something. Definitely not base -10. And it's also, I highly doubt it's used in modern computer systems. Alright, so how about the episode about fractional and irrational bases? What would be some fun facts and demonstrations for YouTube? Okay, if the YouTube episode included base phi of the golden ratio, uses that as a base. Here's some fun facts we could have said about that, which was in my fractional and irrational bases. How to write numbers using the golden ratio and its conjugate as digits. Those aren't the digits you use, although they're useful. Okay, they're just restating all the stuff they said before. No, that didn't help. We'll try one last one of these, which is, what about base 2i? That uses I as a digit. Usually, no, it does not. In addition to 0 and 1. And no, it does not usually use this set of digits exactly. They're just restating this whenever I ask them. Oh, that's way too boring. Okay. What would be a really exciting and surprising way to demonstrate facts about math? Let's see if they say break clocks and light stuff on fire. Props and activities, a deck of cards. That's not bad. Music and multimedia. Yep, we like that. Audience participation. You guys can help me solve it. Yep. These are all pretty generic, but, you know, it's not saying I disagree with these. They're true. A little bit generic. They could have said you gotta shatter some clocks and explode stuff if you want people to learn. Maybe I would be relate to that. But yeah, that's all right. Okay, that's not crazy enough. How could I make it really insanely surprising and chaotic? Use unexpected props or materials like food, water, or household objects. Yep. Visual effects or illusions. Yep, those are fun. Physical comedy or danger. Now they're getting closer to us sometimes. Math tricks in a thrilling way. For example, I could ask audience members to help me solve a math problem in a time-limited or high-pressure situation. Alright, I'm going to be like, alright folks, solve this equation in the next minute or I'm going to get eaten by this shark. And then, or this one, involve them in unexpected or humorous ways. Like I'll start pranking you guys somehow. Please note it's important to take safety in consideration. That is true. Especially ones that involve physical or hazardous elements. That is very true. Okay, I like where they're starting to go here when you ask them for making them extremely surprising and chaotic. Which number would be the most crazy, insane number to include in this epic, chaotic episode? It's difficult to say which number would be the most crazy insane. A very large number, such as Google or Googleplex. A very, very small number, like a negative power of 10. Um, or a number with a lot of decimal places. A number that has a strange or unexpected property, such as a prime number, a palindrome, or something that's famous. You know, we've talked about these for sure. A number with special meaning, like all these things. Thank you. And, all right. So, what is a really, really, really small number I could include? A negative power of 10. That's a good one. Although, did they get 1, 2? No, they got the place right. A number with a lot of decimal places. That is a lot of decimal places. A number that is closer to 0 than any other number. For example, you could use this, which apparently this number is closer to 0 than any other number. These numbers are used to represent infinitesimals in math. No, this can be a thing used in math, but it is not written as this fella. Yeah, let's ask it about this one again. Tell me more about how that is closer to 0 than any other number. Which I will refer to as X for simplicity. Thank you. It's known as proximity. It's if its magnitude or absolute value is smaller. For example, that is closer to 0 than that because that. Similarly, the number X is closer to 0 than any other number because that magnitude of X is smaller than this really official equation. So yeah. Okay. Well, what about this computer? If is closer to 0 than any other number, what about that divided by 2? Which is also an infinitesimal. Is even closer to 0, so it is. Another. Yeah, this isn't how infinitesimals are written or work. Okay. How about a really big number? Bigger than Googleplex. It is difficult to define a number that is bigger because it's already an extremely large number. It's not really difficult to. What? Google is a number that's 10 to the power of 101. I think they meant to put the power there, but just like, there we go, all lumped together. If you were to write a Googleplex, okay, okay, yep. It's difficult that this computer can't think of a number bigger than Googleplex. You won't believe this. I found a number larger. Oh, no, wait, they did one here, which is a number larger. Yeah. I was going to add some to Googleplex. They know that if we go it, that it gets bigger. So it's not difficult to imagine it. I don't know what you're going on about. Okay. What is Googleplex minus 1 in full form? This would be a lot of 9s. Oh, they're just saying it's big. Wait, what? Okay, this is a little weird. If we subtract 1 from a Google, we get a number with 100 zeros, like before, followed by 1 9. And then we get a Google of zeros followed by another single 9. It would be all 9s. Yeah, lots of interesting thoughts. I'm going to ask it 1 or 2 more about this. And then we have one more little activity in a minute. So what'll be our last question for now? Our last question will be... so here's what I'll ask it. It was saying ways to do crazy stuff for the videos, but how they gotta be safe. I'll ask it, what are some examples of ways of demonstrating math for a video that would be too chaotic or dangerous to do safely? There are many ways to demonstrate math concepts in video, but some methods may be too chaotic or dangerous. Using explosives or other dangerous materials. For example, oh, here's where we're going to get all the good ideas, folks. When we ask them for other things that we're supposed to do, they give us some boring ideas. Now, when we ask them for what we're not supposed to do, here's where we might start getting some fun ideas. I'm joking, we're not going to really use dynamite, but you know what I mean. This is way more fun to think about. Using dynamite to demonstrate the concept of explosion, or using, well, we kind of have done this, fire to demonstrate the concept of energy, using weapons or using a gun to demonstrate the concept of trajectory, or these are quite different in scale. I feel like we've probably at some point used a knife to demonstrate the concept of cutting. We have not used a gun to demonstrate the concept of trajectory. Although I did buy a new bubble gun recently, and it's a cool new type of bubble gun you'll see in my episode soon. Hazardous materials or substances like poison or electricity. Physical stunts or tricks like concept of balance. Yeah, so I like these ideas, robot. Okay, so that was our fun little chat with the robot. And then we are going to... And to people leaving a lot of comments. Hopefully I'm back. Please come back. Okay, when am I returning? Okay, I'm back. That was probably my internet being weird. Hate when that happens. Gonna have to figure out some solution to that in the future. In any case, here we have Desmos that I've played around for on a bit that we're transitioning to. And on here, what we have is... someone told me before that you could make your equations have sound. And I tried to pull it up, but the shortcut wasn't working. And I figured out why is because when we graph our super crazy ones, like sine of y squared plus sine of x squared equals 1, are crazy ones, and we try and do the sound, it tries to do the sound like going across a thing or going down a curve. And it doesn't know what part to go across here. And I wasn't able to just select part of it because it's this whole web going on. And if I select all of it, here is where you're supposed to have the music. And it's just not clickable for this guy. But you can do music for graphs. So we just need graphs if we're gonna hear them, which we can bust out this musical tool when we want to. Is when the graph just like seems to be like more of a straight graph or something. I haven't fully tested it out, but if we just do something like y equals x squared, now let's try and click on here and make the sound go. So I'm gonna have to turn this up and see if you can hear it. How do we click on part of it? So, I guess it wants me to start there. Okay, I'll start there. Can you folks hear that? It sounds super weird. It's like dips down in the frequency of how high the frequency is. So, we got that now. Someone has a quick request on it. We can try the request real quick, but then we will try a few more of the sign related ones that might be straight enough to give us noise. Someone's recommending x plus a, x plus b over y, and we're gonna need sliders for these, I guess. This is if they're at 1, so we could move them. They can touch there. They can touch when those are like that. Can we get sound? Whoa, that sounds weird. Okay, so now we're going to check out the sign related ones. Like, if we do sign, we should get some sort of up and down. Now, if we do one of the weirder combos, like sine of tan of x, let's see what this gives us. This is going to be a little chaotic. Okay. Is there a way we can slow that down so we can stretch it out more? How can we slow that down? What happens if we go 1 over x? Oh, that just condensed it all in one spot. Okay, that's going to be chaotic. Maybe if we divide by something, will that stretch it out at all? Nah, that smushes it that way. What if we put the a over here? Will that smush it out at all? No, it's just smushing it that way. I want to smush it side to side somehow. There we go. Let's try one of these. This is going to be really crazy. Warning. So, not that many are going to have the sound work for them of the really cool looking graphs we do. And to whoever's leaving so many comments, chill out on the comments a little bit. I need to leave room for other people to comment. So, let's see. That was sine of tan of 1 over x. What if we switch these? Tan of sine of 1 over x. That one is pretty tall. I want to get more stretched out ones somehow. Not like that. Okay, so this one will be chaos. I don't know what this is going to do. Alright, warning. Not sure what this will do with the sound. Does it sound different if we try and zoom in, like the rate? It goes through this weird part. Yeah, it's like only showing the parts we see, I guess. Now, let's see. Is this going to be able to do it, or is it too weird? That's trippy. Alright, so what if we go this way? So let's see what else we got. The ones that I really want to see are the ones that look too crazy for it to maybe even work. I don't think it's going to let me hear this because it goes over itself in weird places and goes backwards looking. And so we need ones that are cool but not quite that weird. Let's see. What's this one gonna sound like? Alright, we'll stop doing the sound in a minute too in case it sounds super... I don't even know what it sounds like going back into the computer. Sounds pretty chaotic on my end. Yeah, so at some point people can leave comments if they think there's good ones to run the sound on. And for now, we might just try a few of the other weird varieties that were fun to mess around with the other day, where we were doing like signs and weird stuff. There was a cool one I was fiddling around with earlier, which was something like, if we take, first let's take this. The sine of the tan of x is the tan of the sine of y. No, I mean y is x. So this gives us some weird curves to start already. And then the other ones that we can add, at first I tried to put them, well, first I tried to multiply them to each other. So they were both x, y. And we got this thing. Then I tried to put them to each other's powers. And it only goes in a little region and has trouble doing like any of that region apart from these strips. It's just too much chaos at a small scale going on there. So then I tried putting this a little further out. Oops. So I was like, maybe a little further out will work. And then I was like, that's cool, but what if we took it even further out? Oh, wait, no, I accidentally replaced them in a weird way. So this one needs to be x to the power of y, and the other needs to be y to the power of x. Oops. And look at this weird one. So it's not comprehending all of this. There's like this infinite stuff there that's glitching it, that it can't get. So it has these gaps. It's like not getting it all. But you can see some of these things. There's like an actual normal oval like rock thing there. Then this like infinite pancake stack going crazy. And then a little top bit. And then if you go down, you get another one. They're like these little rocket ships. And they all have a slightly different structure. Like what size of base they have, how far apart they are. They're like all these unique little weird little rocket ships flying up at different places. I like the ones like this. These are the type of ones I want you folks to be on the lookout for. They're extra cool to me. The ones where you have like a bunch of different creatures separated. Where there's this big evolved like web, but each spot of it is like a different blob with its own character traits. So now we're going to try just switching some of these around to each other, like if we got sine. It's still having trouble comprehending some stuff going on here, I think. Or is this one just missing that space? Oh, this one might just be missing that space. Whoa. Look at this one. So it looks like you're like, why does it like, there's a few and then hops up a row and then goes up a few and then hops up a row and goes up a few. But it's really just that this row like shrinks to nothing. This starts a little bigger but shrinks to nothing. Starts a little bigger but shrinks to nothing. And then here we get these brackets. That's funny. Look at these nice parentheses and then they come kind of brackety. This one's a trip. Whoa. And then if we went all the way out here, we can't see it at that scale, but all these weird little web of pebbles. Now, from there, what we'll try is replacing a few more. So we had 2 signs there. This one, not sure what that one's trying to do. We'll switch that one. Switch that one. Oop, and that one's cool. Look at this one. This one's a weird zone. You have X's. You have almost X-y things. You have sideways, or in both, or you have parentheses. You have these squarey bracket guys. You have normal bracket-like things, and you got these ovals and circles. Now this one looks like it goes on infinitely. This one doesn't have as many like gaps it ends up on. Creates these strange grids. That's weird that this row just gets a hole in it. They get spread too far apart. That one's cool. So what else could we do here? This one could have switched. Kind of already tried that. We'll put both of them of sign on the outside. Ooh, and this one's weird. These are the not getting all the depth infinity things, but it's definitely like different zones of these little creatures. So those are wild. What happens if we switch some of these to the other ones we haven't tried as much, like the secant? Oh, these are interesting creatures. Oh, these are creepy looking. It looks like you stumbled into some weird series of glyphs. I like this one. That's interesting. As you go up the diagonal, they keep having this X in them. So it like whoa, and this diagonal almost preserves that trait too. You sort of like preserve a trait as you go up the diagonal and what the center guy looks like. And this is like sideways of this one. This one's cool. And they don't want to be in those other regions, so this one's like right on the border. So, yep. What else can we try? I'm just trying weird variations of this right now because it was interesting. Ooh, this one has some strange glitchy guys. Yeah, lots of strange ones. What are all the ones they have built in with nicknames? Yeah, we could do cosecant too, and cotangent. These ones are trippy, you know. Cotangent. A lot of little critters. What about some combo of those? So these are all fun. I like going along with my wild ones. Hello to all the new people saying hi. Let's pause on our graphs for a moment right now. We'll celebrate the 2 really cool ones that I already wrote on my wall over there that were just so simple I couldn't not put them on there. Oh, and I forgot, doing some of those as inequalities would be even more fun. So what was one of those that worked well? There was like tan of sine of x to the y equals sine of tan of y to the x. So something like this. I forgot what we could do to make it even crazier is try and make it an inequality, and then we get filled in zones where it tries to guess where it's supposed to be and where it's not supposed to be. And this shows the homes of those critters I was talking about. All those little critters have their own habitat. And if we keep that inequality here, we'll just see a few more examples of how that gives us like cool messing around ground. Now these hourglass guys are like that. And these ones become square-like. Alright. So, those are fun. We'll do more inequalities. The one that reminded me of on the wall real quick is this one we saw the other day. Sine of x times sine of y is less than or equal to sine of x over y. Whoa! How is this equation that? That's so crazy. This is so wild. Wow. Alright, that one's pretty wild. And we got one more, and hello all, one more request here, which was r equals 2 plus cosine square root cosine 2 theta well, that didn't make much. That made some perfect parentheses. I guess that's good if you want some perfect parentheses. Unless I did something wrong there. So, it could be useful when I need some parentheses. In any case, I think I'm going to pause on our Desmos for now. Always fun to check out these wild graphs. So, remember to keep your eye out for anything involving those weird little single-celled zones especially. Those are super cool. Or just anything wild like that last one we saw. And we are going to transition back to me for a moment and not have too much longer on our stream today. Little more chatting and maybe stories and maybe petting Dandelion back there, and then we might wrap this up. So if anyone has any thoughts or questions, feel free to leave them. And to anyone who missed earlier in the stream, roll that back sometime later to see all of my announcements for when cool things will be coming out in the rest of grade -1. We definitely will be able to have some more absurd bubbles in shots because I've bought another thing of the bubble solution, so we have a lot more bubble mix, and a lot of other rarities that I don't want to show you until in the episodes. And so let's see. Yeah, I think I'm going to wrap up pretty soon. The rain has gone crazy, so I'll have to keep you guys tuned on, or keep you posted on if tomorrow I film the rest of my calendar episode or have to film that another day, and whether my yard floods again. So there'll be more footage and streams and such, but there may be some indoor ones this week because it's going pretty wild out there. And it is contributing to the chaos that the end of the grade classroom gets, so a lot of chaos back there right now. In any case, love all of you Combo Lords for watching. A lot of cool stuff in those upcoming episodes. The next episode on the main channel will be a bit casual. It's bubbles and rain and stuff, but it's pretty fun. That'll be in a few days. Make sure you've checked out 2 prime-related things I've dropped recently. The main channel episode about primes, and a bonus channel one on this channel I put out today. that's also about primes, because the bonus channel one's kind of just about some shortcuts about if you were calculating whether a number is prime yourself, and the other's about a less computationally efficient but very beautiful formula for the primes. And so those are some new priminess to check out if you haven't yet. Make sure to check out all those cool links in the description here. And thank you all so much for joining me. I will make sure to stay safe with that rain and flooding. And hello to all the last comments popping in. Love you all so much. I'll catch you again soon. And until then, hope that you guys don't have any too crazy rain anyway. And someone said I didn't take their request. I'm not sure what they mean a request on. If you mean on Discord or something, I mostly just go on there when I have the chance just to say hi and make announcements and reply to some of the comments and stuff. I'll check through there more later and stuff, or I'm not sure if you mean something else. But in any case, all of you are awesome. I'm going to log off now, and I guess for your finale, we will get a little bit of seeing Dandelion, because he is such a sweetheart, and he is so soft, and he's been hanging out in so many of the streams recently, and it's a good boy. Very soft. So, yeah, there's our Dandelion cameo for the day, or our cat meow, or cameo. And, yep, floods and mudslides. Someone's saying around here, yep, there are some floods in the more rivery zones. My yard will get a mini flood again, perhaps. So, we'll see. Love you all, and